right. Hello, I'm Aya. I'm awesome, hence the name. But without further ado, let's get started talking about data recovery. Psych! No, we're not. Before we do that, I really need you all to understand something very, very important, which is that we're going to be talking about how to recover data. But just because we are going to be going over how to do this doesn't mean that I think you all should stop backing up your data. That's exactly what that's exactly the opposite of what I'm telling you. Please, 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 please still keep backups, because there will be situations where either forensic tools cannot help you at all, or their abilities to help you are limited, or they can get all of your data back, but it's going to be a pain and it's going to take hours, and it would be really just so much easier if you just kept backups. So if you are going to take one thing from this talk, it is that you must, under all circumstances, always keep backups. Please keep that in mind. Okay, now we can actually talk about data recovery. So, why do we need to know about recovering data in the first place? So this might feel like a stupid question, because I'm sure that a lot of you guys have fallen into this first category over here, where we made oopsies. You were modifying something you weren't supposed to be modifying. You were tampering with something that you shouldn't have been. You accidentally deleted something. Oh no, stuff is gone. Oops. The other situation that you could be in is if malware infects your computer, then you might have it start writing to disk and start corrupting your data. And then another common reason is that sometimes your computer will randomly shut down and you were still doing things, and oh no, all of a sudden things got lost. And so this is common enough and a general purpose, general user problem. So this is not like specific to people who are just doing advanced digital forensics kind of thing. So there are tools that are available to help with data recovery in most operating systems. So there's FSCK for Unix-like systems, and then there's CheckDisk for Windows, where your operating system is basically taking advantage of the fact that there is a very well-defined method for writing to disk. And so if you look at enough context, you can tell if something is wrong, and you can maybe infer what should be there instead. And so before we talk about the recovery process, I feel like it's worth it to talk about how deleting happens in the first place, so that we understand what we are trying to get back. And so the main thing you need to understand about deletion is that it's very easy to say that something has been deleted, but it is much harder to actually do it to the extent where it's not recoverable anymore. So what it's gonna look like for you is like you will see this folder on your desktop, and poof, all of a sudden it's magically disappeared. And then this might not be a folder. This is just a general example. It could be a file, an entire folder, or it could even be like a whole partition on your drive. In general, what this looks like on disk is there is some sort of header or reference to the actual data. And so writing to disk is expensive, or at least it takes longer than anything else your computer can do. And so this actual data here is not to scale. It could be hundreds of gigabytes large for all you know. And it's just not worth it most of the time to actually go and like try to get rid of this data. So your computer will just kind of like get rid of that reference there and like do a little bookkeeping and be all like, haha, I don't know what data that would, no, we don't have any data. It's gone, deleted, poof. And then that's what you see. And so this is fast, but it's kind of unimpressive because, like I said, there's like a lot of context still left. And so this is how FSCK can like look at your drive and be like, oh, well, you know, something is like missing, and I can very easily piece together what that was. But if we want to actually delete something like to the point beyond recovery, there are two perspectives that are taken in forensics. So one is you want to achieve clearing where software cannot recover it, and you want to achieve purging where lab equipment cannot recover it. So one option, of course, is you could just obliterate your disk. If you wanted to, you could put it in a shredder, a really, really good shredder, and then it's destroyed. Nobody can read it. Nobody can recover any data. So obviously you've achieved both, but this is kind of extra. This is what Google does. This is not what normal people do. Us normal people take a less destructive approach, but it still does what it needs to do if you can do it right. So it's called data sanitation, where you essentially just overwrite the data. And if you do it right, then it will clear and purge your drive. But there's that little caveat if you do it right. So how do you do it right? Let's talk about that for a second. So, for example, let's say that you work at a company and every few years they're like, we want to update to the latest hard drive technology, and then we're just going to have these old hard drives and we want to sell them, just make like pretty penny off of it, right? But you are an ethical and responsible person, and so you think to yourself, well, there could be sensitive or confidential data on that drive, and I'm going to do what the ethical and responsible thing is, and I'm going to overwrite that data, right? And so you're like, well, I have a brilliant idea. What if I just go through the whole drive and I overwrite it with a bunch of zeros, the entire thing, just clear it all with zeros? Is that enough? So the thing is, a bunch of really smart people and a bunch of government agencies have been debating this for like 30 years now. And the general consensus is maybe. So the National Institute of Standards and Technology, NIST, they say that one pass over the entire drive is enough. There are some European agencies that say, no, you should do two, or no, you should do three. The 3-pass method is pretty famous. It was first proposed by the Department of Defense, but since then they've like retracted, and now they're just kind of like, you do your own thing, guys. But 1 to 3 is generally the consensus. There have been some other bigger numbers, but that was for older technology where it was much harder to actually overwrite the data. Most modern drives, overwriting it once is probably enough. So let's try the same thing, but now we want to do it with a phone. And you're like, yeah, I'm just going to sell my old phone. And, I want to get rid of my personal data on that before I do that. So I'm just going to do the same thing. I'm just going to overwrite the entire thing with a bunch of any random character. So is this going to be enough? Maybe. It's harder to do it right. So the reason is you're now working with a solid state drive, and that is, by the very design of it, harder to achieve because they're meant to be more physically resilient. So even if you wanted to take Google's approach and like destroy it, they're harder to destroy. And then solid state drives also do something called where leveling, where they distribute where things are actually written to. And so in order to be actually able to write through the entire disk, you need some very special commands so that you are actually able to achieve the entire, you are able to actually overwrite every single part of the disk. And then if you wanted to do multiple passes, so 2 or 3, you also incur the cost of wearing down your drive prematurely, and you reduce the lifetime, right? So what was the point of me going over like 5 whole slides dedicated to just how we delete stuff? The point that I'm trying to make here is that it's really hard to actually delete data to the point where you cannot recover it. So what that means is it's usually possible to do some level of data recovery. But I'm going to put this in here again. please. This does not mean you can't do backups. Again, the one thing that you should be taking away from this is that you still need to back up your data, because data recovery is not always going to mean full data recovery. Just because I can get back part of it does not mean I'm guaranteed to get back everything. So let's talk about the actual recovery process. So I have included the general strategy for what you want to do. I realize that some of you may be expecting to apply this to like forensic level CTF problem. So just know that these first and last step are probably not going to apply in a CTF. But in the real world, if you do have a lot of data to go through, it could conceivably be hundreds of gigabytes, if not multiple terabytes large. And so you want to reduce your search space. And so there are techniques for finding redundancies in data and then narrowing down what part of the drive that you want to focus on. And then from there, you figure out what the problem is. And by you, I do not actually mean you. I mean some sort of general purpose tool that you can have scan your disk and be able to tell you like, hey, yo, I can't read the partition table. It's probably corrupted. Or the partition that there's like a recently deleted partition. Do you want me to help you recover that? Or something like that. I don't expect you to look at a bunch of ones and zeros and figure out what went wrong. But then from there, you either keep using your tool, or if you have to, then you need to go out and find another tool to like specifically deal with your problem. And I'll talk about that in a second. And then undelete, and if you need to, uncorrupt. And then afterwards, if there's still data that's corrupted that you can't get rid of, you need to remove that before you start analyzing any of the data. Because if you try to read and then you get to a bad sector, you won't be able to read past that sector. And so just so that you can able to read everything, you want to remove anything that was still corrupt. But in general, you shouldn't be getting anything in a CTF that was corrupted and could not be uncorrupted. That doesn't seem reasonable. Anywho, in terms of finding the right tool for the job, you want to think about the extent of the deletion and the corruption, and the extent of recovery that you want to do. Specifically, how big is the data that you want to get back? So if you want to recover an entire partition, that's going to probably look different than if you just want to find one single file that was deleted. Not probably, it will almost definitely look different. And then something to keep in mind is the file system that you are using. So different file systems work differently, and the way they keep track of data and keep track of files is going to be different. And so certain tools are better and more specialized in certain file systems than they are in other ones. Oopsies. Oh no. So some examples of tools that I've seen people use for like CTFs. These are your general purpose ones. Test disk is pretty nice. It's got a heavy emphasis on being able to help you with partitions. So things like fixing partition tables. It also does reboot sectors, and then it has some extent of file recovery that it can do. And then the other one that I've seen people use a lot is Autopsy, which is really just a front end to the sleuth kit. And the sleuth kit is like this giant library of a bunch of different disk analysis programs that you have access to. And so it's really good for like general forensics problems in general. But like an example of where you might need to stop using your general purpose ones and then try to find something a little bit more specialized is, let's say you're trying to recover something from an ext4 system. So that's like what Linux uses. So then you could use test disk, and test disk can find metadata. So it can tell you like, oh, this folder was recently deleted and this was the name. And these are like some information about it. But if you actually try to store the contents, it will not be able to. It works on certain file systems, and ext4 is not one of them. And so you might want to find something like ext on delete, which is a program that is very specific to recovering file contents from ext3 and ext4 file systems, right? So that's where the whole file system thing comes into play. So before we end, I have a pop quiz. I actually expect you to answer. True or false? Keeping backups of data is only for noobs who don't know about data recovery. I swear if you get this wrong. Robert! Okay, all right. No. I'm so disappointed. Guys, what was the one thing you were allowed to... No, the answer is false. Okay, if you guys have any questions, I can take them.